Hello, my name is Keith Clifford, author of Flash Insight, an in-system gang programming tool for Windows which I'm about to demonstrate for you. I'll be demoing support for the NXP Kinetis family of devices using the latest release of Flash Insight. Then I'll be demoing forthcoming support for the STM32 family of devices and a new feature running a RAM image, both of which are currently under development. I'm new to making video recordings, especially of myself, so please bear with me as I work out the kinks. Let's get started. The first demo setup has two Freedom K64F development boards. They're connected to Flash Insight via an Adafruit FT232H breakout board and an FTDI FT2232H mini module. And each board is logging via UART4 transmit to a terminal emulator that will be displayed along with Flash Insight as we do the reading, programming, etc. So this is where things get interesting. This is Flash Insight, the window on the bottom here. The two windows on the top are logging the output from the serial port of each of the target devices. I've pre-configured three projects, one for each of the targets that I'm going to be demonstrating. If I want to save a project, it's as simple as save settings as and enter a suitable name. We'll be starting with the Freedom K64. First off, we want to configure it. We want to select the device. The target device here is a 1 megabyte device. That's a list of all the supported devices. Depending on the programmer, the configuration will change. For our purposes, we need to configure the SWD clock, which I've set to 2 megahertz. I'm talking to COM13, which is talking to the device logging to the window on the left. And we see that device reset. I switch over to the device on the right. I see that device reset. If you recall from earlier in the video, COM7 was not connected. Mini module B was not connected. And as expected, we get no target detected. Read. Browse. I already have a file with this name created, but we're going to just overwrite it. Oh, and let's select something that we're actually connected to. And we'll try again. So while we're reading that, the images that I'll be using are built to make Flash Insight. They're built for testing Flash Insight. We'll do a blank check. So the images are very basic. They do some logging, they toggle an LED, and basically they fill up the amount of memory that's to whatever size of image I want to test with. Erase has 3 options: erase all, blank check, and erase. So if a sector isn't blank, if a sector is not blank, it'll erase it. And erase using the erase list on the right here. You can select which sectors you want to erase. I won't bother doing this because we'll be erasing as part of the programming operation here. Verify after programming, reset after program, verify, and we'll be doing a full licensed version of the program. I'll explain the licensing while it's loading because it takes about a minute to write a 1 megabyte Kinetis part. So licensing to program a target device, to program more than 3/4 of the target device, or 3/4 of 32K, whichever is smaller, you need a license And there are separate licenses for single port programming and gang programmer. The gang programmer I'll be demonstrating in just a moment. So verify using a different file format but the same image. It reads back the entire device, reads back the entire flash, and compares it to the listed image here. And this image doesn't need to be the same image that's set in program. Go basically does a reset. And that's about it for single port programming. For gang programming, all of the parameters are set here are used in the gang programmer, except the port changes depending on you select which port you're communicating with the target device in the gang programmer. So we're programming, set up to program all devices, and away we go. So while I'm doing that, while it's busy programming, once this is complete, I will set up to demo the other two programs, or sorry, the other two projects that I have set up. And the only reason that I don't have them already set up is I haven't made up enough cables. There's no reason that I can't have all these projects set up, ready to go, and just select whichever program I want to run in the moment. So if you'll excuse me, I'm going to go away now, and I will be back in very shortly with the setup to test the K32 and the KL03. And I'm back now with basically the same setup, but this is a Freedom K32 L2B3, and this is a Freedom KL03Z. And now we'll be going straight into Flash Insight. And we're back. Since you're familiar with most of the operations now, we'll go straight into programming. The K32L2B3 is a 256 kilobyte part, and that's how large this image is, and it takes about a quarter of the time that it takes to program the Freedom K64. It's done, it's rebooted, and everything looks good. Let's try the KL03Z program. This is a 32K part, so it is much quicker to program. It's rebooted and all looks good. Next, I'll be giving you a bit of a background on the FTDI devices that I use for programming the various parts that are supported. I'll see you in a moment. And we're back with a selection of devices that I use to provide the electrical interface between Flash Insight and the target being programmed. If the programming protocol uses asynchronous serial, then any asynchronous serial port will do as long as you get the voltage levels right. If the programming protocol uses some other serial protocol, for example ARM-SWD, JTAG, SPI, I2C, then I will use one of these devices to provide that interface. This is an FTDI UM232H. This is an Adafruit 2264 breakout board. These are based on the same FTDI chip, the 232H. This is an FTDI FT2232H mini module, which has 2 ports. And this is an FTDI 4232H, which has 4 ports, but only the first 2 ports support the multi-protocol synchronous serial engine, or MPSSE, that I used to provide the serial interface. Each of these boards has a different electrical interface on the target device side, so I've added daughter boards to bring the electrical signals out to a standard interface. I'll be back shortly with a demo of some new development. See you soon. One last note about these boards. Beyond providing a common electrical interface, I haven't modified them in any way. So if you have another board from another manufacturer that uses one of the FT232H devices, feel free to give it a try and let me know how it goes. This is the demo setup for the Flash Insight STM32SWD programmer. Here I have two Nucleo F411 development boards connected to two FTDI breakout boards, one a dual port, the other a quad port. One of the unused ports on each of the breakout boards is connected to serial transmit from the development boards. And I've had to modify each of the boards to bypass the ST-Link section of the board with SWD going straight to the processor. I'll now switch over to the Flash Insight view where I'll do the rest of the demo. First, I'm going to demo gang programming the maximum sized image for the STM32F411. That's 512K. So far, I've only tested with at most 2 boards because, as you can imagine, it would be expensive having a large number of development boards on hand. ST has been kind enough to provide development boards that are relatively inexpensive, so I will be testing with 16 instances with the Nucleo F411 when I get to that point. That'll be in an upcoming video. Now I'm going to switch over to the single device programmer. I wanted to show you that the configuration is going to depend on the the device family. For STM, there is a configuration called the P size, which is the number of bytes that are simultaneously programmed, and it depends on the applied voltage. Right now I'm using times 32, so 32 bytes at a time. There's also a times 64, but it requires an external programming voltage of between 8 to 9 volts, I believe. And there's a warning that don't apply that voltage for more than an hour or you'll damage the part. So I'm playing it safe and sticking with times 32. Next, I wanted to show you the new feature, run a RAM image. This is just I haven't gone to the trouble of filling out the RAM with the image. As you can see on the left, the terminal on the left is logging as having a different printout than the terminal on the right. I do a normal go, which is basically a reset, and I'm back to running the Flash image. That's it. I hope you've enjoyed taking this adventure with me through Flash Insight, and I will be coming back to you with another video demoing the gang programmer with the current maximum number of devices being programmed at one time. Take care and bye for now.